Hey everyone, welcome back to my channel. Today we're going to tackle a problem on LeetCode that's all about ranking elements in an array. It's called the rank transform of an array problem. And it's classified as easy. But don't let that fool you, it's still a great opportunity to learn some new concepts and practice your coding skills. So let's dive right in and see what this problem is all about. The problem asks us to transform an input array by replacing each element with its rank in the sorted array. The rank of an element is its position in the sorted array, with the smallest element having a rank of 1. For example, if the input array is 4, 2, 6, and 5, the sorted array would be 2, 4, 5, and 6. So the rank of 2 would be 1. The rank of 4 would be 2. The rank of 5 would be 3. And the rank of 6 would be 4. Our goal is to create a new array where each element is replaced with its corresponding rank. To solve this problem, we need to understand the concept of ranking. Think of it like a competition where each element is a participant, and the rank represents its position in the final standings. The key insight here is that we can calculate the rank of each element by sorting the array and then mapping each unique element to its corresponding rank. This ensures that equal elements have the same rank and the rank is as small as possible. For instance, if we have multiple elements with the same value, they should all have the same rank. This intuition is crucial to solving the problem. So make sure you understand it before we move on to the solution. Now that we have a good understanding of the problem and the intuition behind it, let's walk through the approach. We'll start by sorting the input array in ascending order. Then, we'll create a map to store the rank of each unique element in the sorted array. We'll iterate through the sorted array, and for each unique element, we'll assign it a rank and store this mapping in the map. Finally, we'll create a result array to store the rank of each element in the original input array. We'll iterate through the input array, and for each element, we'll find its corresponding rank in the map and append it to the result array. Now let's take a look at the C++ code that implements this approach. We start by creating a copy of the input array and sorting it in ascending order using the sort function. Then we initialize an empty map to store the rank of each unique element in the sorted array. We iterate through the sorted array, and for each unique element, we assign it a rank and store this mapping in the map. The line if ranks, find num equals ranks.end checks if the element is already in the map, and if not, we assign it a new rank. We then create a result array to store the rank of each element in the original input array. We iterate through the input array, and for each element, we find its corresponding rank in the map and append it to the result array. Finally, we return the result array containing the ranks of all elements in the input array. The time complexity of this solution is O(n log n), due to the sorting operation, where n is the number of elements in the input array. The subsequent operations have a time complexity of O(n), but the overall time complexity remains dominated by the sorting operation. The space complexity is O(n) for storing the sorted array and the map of ranks. And that's it, we've successfully solved the rank transform of an array problem. I hope you guys learned something new today and had fun doing it. If you liked the video, be sure to like it, subscribe to my channel for more coding tutorials, and comment your approach below. I'd love to see how you tackled this problem. Thanks for watching, and I'll catch you all in the next video. Like the video, subscribe, and comment your approach below.